So the way they have us use these is going to be kind of like in these examples. They could do lots and lots of things with these, but we'll take a look at these first. So for our first example, it says looking at this diagram, and notice with the diagrams, the parallel lines can go all kinds of different ways. So this is where you'll really need to focus on where are my parallel lines, where is my transversal, where is my interior, where is my exterior, and how are the angles related. So if we take a look at this first one, it says if line BD and EG are parallel lines. So there's our parallel lines. So if we have parallel lines, BD is the first one, and EG is the second one. And if you look in the picture, they don't do those little arrows on the lines like they did in the theorems that I gave you. They gave it to us in the problem, and this is enough for it to work. We don't have to have it on those lines. And it doesn't tell us in the problem that we have a transversal, but we can see we have one. We've got a line that goes through those two lines at two different points. Okay, so if these two are parallel lines and angle GFC, so GFC, so I'm looking at this angle right here. If that angle is 125 degrees, what is the measure of angle GFH? So we've got to figure out how this angle right here is related to that angle right there. Well, it doesn't fit any of the ones that we've talked about, and whenever we get into these proofs, it's going to start mixing all of the vocabulary words that we had about angle pair relationships together. So this is an example of where we do that. It doesn't cover any of this is an example of any of the theorems or postulates that we had at the beginning of this lesson. This is just this is how relationships can happen whenever you have two lines in a transversal. So if you look, this can be considered a linear pair. And if you remember, the definition of a linear pair tells us that they are supplementary. And if we remember what supplementary means, it's two angles that add up to be 180 degrees. So if I'm going to list those two angles, it's angle GFC and angle GFH are going to add up together to be 180 degrees. So what is GFC? It tells us it's 125. And what is GFH? We don't know. So I'm going to leave it as angle GFH. But I know it's going to be equal to 180 degrees. So I need to solve for angle GFH. So I minus 125 from both sides. And that's going to leave me with angle GFH is going to be equal to 55 degrees. Okay. Looking at the next example, they say if LN and OQ are parallel lines. So again, they're not marking it in the picture for us. They're telling us in the description for the problem, but they're telling us those are parallel lines. And OPM is 117, so there's our transversal. So OPM right there is 117 degrees. What is the measure of angle NMP? So we're looking at comparing this angle to that angle. And in order to be able to do this, we have to figure out how are they related. So we're going through that list of angles that I've given you, trying to figure out how they are related. And these angles are going to be alternate interior angles because they alternate. They're on opposite sides of that transversal, and they're on the inside between those two lines. So alternate interior angles, if we look at our theorem, it tells us that they are congruent. So if I list that out, angle OPM is going to be congruent to angle NMP. So if I write that down, I'm going to switch it to be equal. OPM is going to be equal to angle NMP. MP. And OPM, they told us, is 117, and that's going to be equal to angle NMP. So that's going to be our answer there. And I know, like this work, a lot of people are going to say, well, do I have to show all this work? And I'm going to tell you yes. And the reason why is we're going to get, very soon, we're going to get to the point where we're having to look through proofs and figure out the reasons why for steps and proofs. And if you write this out, it's going to help you be able to find those steps and say, hey, I know what that step is, easier because you've already put in the practice and you know what it looks like and you've created it on your own. So make sure you're showing all this stuff that I'm writing here. All right, looking at the next example. It says we've got two parallel lines. So we've got TV, WY, cut by a transversal. And it tells us that the angle TUS is 50 degrees. What is the measure of angle VUX? So there's V, there's U, there's X. So we're looking at that angle right there compared to that angle right there. And this is another example of they're asking us for an angle pair relationship and they're pulling from that vocabulary that we had a couple lessons ago. Because yes, if you're looking at this and you're saying, well, this doesn't look like anything that we just talked about, you're absolutely right. This goes back and talks about our vertical angles. And when you're looking at vertical angles are going to be congruent and equal. So we're looking at angle TUS is going to be congruent to angle VUX. And notice I peeked to make sure that I'm putting the letters in the same exact that they're asking for in the problem. So I'm going to switch it from being congruent to equals. And then it says TUS, we know it's 50 degrees, so we can say angle VUX is going to be 50 degrees as well. And it's because we had vertical angles. All right, looking at the next one, it tells us LN and OQ are parallel lines. So there's LN, there's OQ. There's our transversal. So I'm just double checking to make sure that we can use the theorems and proofs that I gave you. Remember, every single one said if you have two parallel lines, if you have a transversal. So you've got to check and make sure that all that's there, otherwise these rules don't work. So we're looking at QPR. They tell us it's 125. It wants to know the measure of angle NMK. So there's NMK. Well, looking at those angles, they're both on the outside, so that means I can talk about exterior. So I'm looking at exterior angles, and they're both on the same side of the transversal. And if you remember, our word for same side is consecutive. So we're looking at consecutive exterior angles, and if we look back at our theorem, consecutive exterior angles are going to be supplementary. And if we remember our definition of supplementary, two angles that add up to be 180 degrees. So that tells me that angle QPR plus angle NMK are going to add up to be 180 degrees. So QPR is the one I know, and it's 125, plus angle NMK, the one I want to find, is going to be equal to 180 degrees. Subtract that 125 from both sides, and angle NMK is going to be equal to 55 degrees.